Right now, it feels like the entire world is talking about the AI race. Who's got the biggest model? Who's the fastest? Who's gonna win? But what if we're all so focused on the finish line that we haven't stopped to ask if we're even running in the right direction? Today, we're gonna dig into a different way of thinking, one that really questions the very foundation of how we're building artificial intelligence.
See, the main idea in AI today is pretty simple. Bigger is better, right? Just keep feeding the beast more data, add more parameters, throw more computing power at it, and poof, it gets smarter. But what if that core assumption is actually leading us down a dead-end street? A path that's not just getting crazy expensive, but is creating these AI systems that are total black boxes, unpredictable, and fundamentally out of step with how the real world actually functions.
So first, let's really break down this main approach, what our source material here calls the monolithic approach. This is the whole philosophy of building one single gigantic AI model that tries to be a jack of all trades, and, well, you know how that ends.
And this is where you start to see the cracks. When you just dump everything into one giant, tangled-up model, all of human knowledge, every skill you can think of, every single industry, you get a black box. It becomes almost impossible to figure out how it's making its decisions. It's not built for the specialized way we actually work. It basically shoves humans out of the driver's seat when it comes to governance. And this is a big one. It's a complete nightmare to update or evolve safely down the road.
Okay, so if the bigger is better plan is kind of a flawed blueprint, what's the alternative? Well, the answer isn't just more brute force. It's about a total change in how we think about it. What if we stopped trying to build a single giant brain and instead we modeled AI on the most complex and successful intelligence system we know, human civilization itself?
This quote really gets to the heart of the whole idea. Just think about it for a second. We don't have one single person who's an expert in everything. Of course not. We have engineers, we have doctors, artists, economists. Our knowledge is structured. Our work is specialized. Our entire society is this massive, coordinated system of experts working together. And the big idea here is that a truly useful AI has to mirror that same elegant, collaborative structure.
And when you put them side by side, the difference is just stark. On one hand, you've got that single opaque brain, a brittle system that can break in ways you'd never expect. But on the other hand, you have a coordinated team of experts. It's modular, it's future-proof by design, and it isn't just randomly misaligned with our world. It's built from the ground up to be explainable and economically useful.
So what does this actually look like in practice? How do you build this? Well, let's take a look at a specific architecture that's built on this very principle, a system they call KRIS Intelligence. And it's designed as a network of exactly 10,000 distinct, governable experts.
The whole system is built on this really logical, repeatable pattern that actually mimics how we apply knowledge in the real world. You start with the foundation, academic knowledge. Then you translate that knowledge into practical skills or capabilities. And finally, you apply those capabilities to solve real problems in specific industries. It just makes sense.
Okay, so it all starts here with the foundation. We're talking about the roughly 340 distinct engineering disciplines that exist in the world. Things like civil engineering, electrical engineering, software engineering. This is the bedrock of technical knowledge. It represents the fundamental principles of what humans study and know.
Now, from that foundation of knowledge, you build the next layer up. Those 340 disciplines get broken down into about 1,500 reusable capability experts. Think of these as concrete roles like design and architecture or safety and standards compliance. These experts are all about defining how things are built. And the cool thing is, they can be applied across a ton of different industries.
And this is where it all connects to the real world. Those capabilities are then mapped onto the actual economy, creating 8,500 sector experts. Now, these are aligned with official industry classifications, the kinds governments use, and they define where intelligence gets applied. We're talking manufacturing, healthcare, finance, you name it.
So you add it all up, and you get to this number, a locked, structured system of 10,000 experts. And it's not some arbitrary number they pulled out of a hat. It's the direct result of a really deliberate bottom-up design that maps the world of human knowledge directly onto the world of economic activity.
You can really see the clear logical flow here in this table. You go from the academic foundation of what we study to the practical primitives of how things are built, and then finally to the real-world application of where that intelligence is used. Each layer has a totally distinct role, and it all builds systematically on the one that came before it.
Okay, so a system of 10,000 AI experts is one thing. That's cool. But maybe the most critical piece of this whole architecture is how it makes sure that humans don't get pushed to the sidelines. Instead, they're actually woven right into the fabric of how this thing is governed and how it evolves.
And this is done through a platform called OmniMind. It's not just some user interface you click around in. No, it's a social intelligence platform where real human beings actively govern and help shape the AI's development over time.
And the really crucial point here is that humans are treated as a fundamental principle of governance. Through this platform, they can actually challenge an expert's logic, they can debate its conclusions, and they can help steer its development. This isn't just a safety feature tacked on at the end, it's about deep accountability and making sure the system always stays aligned with our values.
All right, so with this structure of AI experts, all governed by humans, we can start to zoom out and see the big picture. What does a system like this actually make possible? What's the ultimate goal here?
This quote completely changes your perspective, doesn't it? We're not talking about another consumer app for writing your emails or making fun pictures. We're talking about foundational infrastructure, an operating system that can manage and deploy intelligence across the entire economy.
And this is why it all matters. Why go through all this trouble? Because a structured, explainable AI is something you can actually trust in high-stakes critical situations where, let's be honest, monolithic models just can't play. We're talking about running industrial systems, managing public infrastructure, even coordinating fleets of robots for missions to other planets. These are areas where you absolutely need to know exactly how and why a decision was made.
I love this quote because it really captures the long-term vision. The specific AI models we're all excited about today, look, they're going to be replaced by better ones tomorrow. That's just how technology works. But by focusing on a stable, logical architecture, the system itself can last and adapt, just swapping out old models for new ones without having to tear the whole thing down and start over.
And so that brings us to the fundamental question that's been underneath everything we've talked about. The race to build more powerful AI is happening. There's no stopping it. But maybe the most important question isn't just about making it bigger, it's about how we design it. Should we keep building these ever larger monolithic brains, or is the future of intelligence in building better, more accountable structures? The path we choose isn't just going to define the future of technology, it's going to define the future of our world.